In this video, we're actually going to review how we solve quadratic equations by factoring. All right, and this is one of those methods that we learned previously how to do, and we just want to review how we can do that. The first thing we're going to do, and now I do want to make sure you're aware that we have equations now. All right, previously, we were looking at quadratics, or we were looking at factoring. We were looking at just factoring or simplifying. That's one way to change the look of an expression. Now we have an equation, all right? And when I say solve an equation, I mean I want my answer in x equals form, okay? So let's keep that in mind as we go through these processes on how we can use mathematics to help us solve for a variable. The first step is to simplify both sides of the equation. All right, just like with linear equations, if we see a distributive property, we're going to distribute. If we see combining like terms, we're going to do that. We're going to also clear our fractions if we see fractions in our problem. After we've simplified both sides of the equation, we're going to get all our terms on one side of the equation set equal to 0. So I want everything on one side, and I want 0 on the other side of the equation. All right. After we do that, we're going to factor. And what's nice about this is after we factor, we can set each factor equal to 0 by using our 0 factor property. And that just means that, hey, if we have two things, I am sorry about that, but if we have two things that multiply to give us 0, then at least one of them have to be 0. And so what we're going to do is after we factor, we're going to set both of those things equal to 0. All right. For instance, if I have a times b equals 0, then I know that at least one of them has to be 0. And so that's how I'm going to go and solve my quadratic equations by factoring. So let's look at a couple of examples. Once we set them equal to 0, we'll solve those equations. Let's look at this example right here. 3x squared minus 16x minus 12 equals 0. The first step was to simplify. That means distributive property, combine like terms, clear fractions. I don't have any of that, so I'm going to go to step 2, which is to get all of my terms on one side. Well, all of my terms on one side, zeros on the other side, so step 2 was actually taken care of for us in this example. Now I'm going to go to step 3. Step 3 is to factor that polynomial there, right? First up of factoring is looking for your GCF. I have a 3, 16, and a 12. All of my terms don't have an x, and those numbers don't have a greatest common factor. So I'm going to multiply my 3 and my negative 12. And remember, this method is used. You can do a trial and error to help you factor. But this method is used. All right, 3 times negative 12 is negative 36. Finding two numbers that multiply to give me negative 36, but add up to negative 16. Negative 18 and 2 will work. So I'm going to rewrite that minus 16x as a minus 18x plus 2x minus 12 equals 0. Now, I have 4 terms, so I'm going to factor out my GCF of the first 2 terms, which is going to be 3x. I'll be left with x minus 6. And out of the second 2 terms, 2 times x minus 6. Of course, we have the same 2 terms when we factor out the GCF of the groups. So I'm going to factor out that term, and I'll be left with a 3x plus 2. So now we're at the point where we have two things that multiply together to give us 0. I have an x minus 6 times a 3x plus 2. So I'm going to set both of those equal to 0. And so the problem with solving quadratics is this squared term right here. It's hard to solve for x when x has an exponent other than 1. So this process here helps us get to where we have x to the first power, i.e. a linear equation in both of these cases here. So these are going to be my solutions, and this ink is out of control here. But if I want to solve for x here, I can add 6 to both sides, and I'll get x equals 6. On this other equation, I can subtract 2 from both sides. I'll get 3x equals negative 2. And then I can divide both sides by 3, so I get x equals negative 2/3. So my two solutions would be 6 and negative 2/3. All right, and I wrote my answer as a solution set, and that is it. Again, since we have an equation, you can check yourself by substituting these values in separately into this original equation and ensuring that it comes out to be true. Let's look at some other examples. I have x times x plus 3 equals 7x plus 32. Now this example, it already has something in factored form, all right? The problem with having it in factored form when there's not a 0 here is that we actually have to unfactor it, all right? So I'm going to multiply or distribute, sorry. That's going to give me an x squared plus 3x equals 7x plus 32. Now here, this is that part where I'm saying that we have to simplify. Once we simplify, right, by using our distributive property, we got to get our terms on one side. All right, I'm going to move this 7x to the other side. And in the same step, since I want this right-hand side to be 0, I'm going to subtract 32 as well. Doing that allows me to make 0 be my only term on my right-hand side. Okay? I can only combine these two like terms, right? They both have an x. 3 minus 7 is negative 4. So I get x squared minus 4x minus 32 equals 0. Now I'm at a point where I can factor, because all my terms on one side set equal to 0. We always have to get it into that point, or we won't be able to use the zero product property, zero factor property. So I'm going to factor. There's no GCF. There's a 1 in front of the x squared, right? And so I'm going to put an x here and an x here. Two numbers that multiply to give us negative 32, but add up to negative 4. A negative 8 and a positive 4 will work for that situation. And so now I've reduced my quadratic equation from having a squared term, which is hard to solve as we look, to having x to the first power as its only exponent. And so I'm going to have x minus 8 equals 0 by our zero factor property, and x plus 4 equals 0. Okay? If I add 8 to both sides, I get x equals 8. And if I subtract 4 from both sides, I get x equals negative 4. And so my solution set will be 8, negative 4. Okay? Let's look at another example. In this example, we actually have fractions. 1/5 x squared minus 1/10 x minus 1 equals 0. Much like we did when we had a linear equation with fractions, we can do the same thing, right? The lowest common denominator, we have a 5 in the denominator here and a 10 in the denominator here. Well, 10 is our least common denominator. And so we're going to multiply both sides by 10, and I'm going to actually have to distribute here to each of these three terms. And so I'm going to have a 10 times 1/5 x squared minus 10 times 1/10 x minus 10 times 1 equals 10 times 0. And there's that again. All right, when I do 10 times 1/5, 5 goes into 10 two times, so I'm going to have a 2x squared. 10 goes into 10 one time, so I'll just be left with x, and 1 times 10 is 10, and that equals 0. Okay? Now we have a case where we've distributed by getting rid of our fractions, multiplying by 10 and getting rid of our fractions. Now we have integer coefficients, which is great for factoring. All of our terms are on one side set equal to 0. There's a 2 in front of my x squared. There is no GCF, so when I factor, I'm going to multiply the 2 and the negative 10. That'll give me negative 20. So I want to find two numbers that multiply to give me negative 20, but add up to a negative 1. Negative 5 and 4 will work. Okay? And so I'm going to rewrite that minus x as a minus 5x plus 4x minus 10 equals 0. 4 terms, so we can factor by grouping. First two terms I can factor out an x. I'll be left with a 2x minus 5. Second two terms, I can be factoring out a 2, and I'll be left with 2x minus 5. And so in factored form, I'm going to have a 2x minus 5 times an x plus 2 equals 0. And this is where my two solutions are going to come from. 2x minus 5 equals 0. X plus 2 equals 0. All right. If I add 5 to both sides, I get x equals 5. And if I divide both sides by 2, I get x equals 5 halves. So that's one of my solutions. In my other equation, I can subtract 2 from both sides, I'll get x equals negative 2. And so my solution set will include 5 halves and negative 2. All right. We're going to look at one last example. X squared plus 2x equals 0. Okay. We're going to solve this equation. All right, first step is to simplify. Again, I can't combine like terms. That's the only thing I can see with respect to simplifying because I don't have fractions. I don't have a distributive property. Step 2, get all your terms on one side of the equation. Well, my terms are on one side of the equation. The other side is 0. Step 3 is to factor. All right, factor that side with all your terms on it. Well, I have an x squared plus 21. First step of factoring. Never forget that because if you don't forget that, it's going to make this type of problem really hard. First step of factoring is to factor out the GCF. I have an x squared here plus a 21x. They both have an x in them, so I can factor out an x. I'll be left with an x plus 21. When I factor in this way, the GCF, if you'll notice, I actually have two things that actually multiply together and they're set equal to 0. So I'm done factoring and all I have to do is set each individual thing equal to 0. So I can set, well, each factor equal to 0. So I say x equals 0 or x plus 21 equals 0. All right, this was already solved for me, so this is nice. And if I subtract 21 from both sides, I get x equals negative 21. And so that will be my solution. X equals negative 21 and x equals 0. All right, so if you want to write it as a solution set, 0 and negative 21. And that is about it. That's it with solving quadratic equations by factoring.